Well, hi class. This section is 4.1, and we're going to be talking about systems of equations. And we learned three different methods to solve those. Those are where you have two equations and two unknowns. Usually we see them as X and Y. In the business world, there typically might be different symbols. Now I'm losing my train of thought. Maybe X is the number of items and your Y is your revenue, or it could be your cost, or it could be your profit. So it kind of, those are more of our business world, right? So what are the types of solutions you can get when you have a system of equations? This is added to before we start the packet. So I'm writing at the bottom of the packet, so you could flip it over and write this there too. So this is our total number of solutions. So I swear I just made that black and now it's purple. I mean, black. Oh, I clicked. Oops, that's what I did. Well, we're good now. Okay, so the number of solutions. So the first case is that you have one solution. And remember, this is a point, X, Y. And if we think about what the graph looks like for this, here's our X, here's our Y. You're going to have a line somewhere, anywhere on here is line A. And then you're going to have a second line anywhere on here. And they cross in one place. And where they cross is that point X, Y. So where, if I graph it, it's going to be two lines, they cross somewhere. Okay, and that where they cross is the solution. So graphing method would look something like this, and you would just find where they cross. So that's our first method, their possible solution. The next one would be no solution. If we're thinking in terms of lines, what two types of lines never cross, so there's never going to be a solution? Parallel. So we have parallel. Is that an A? Parallel? No, I think it's an E. Okay, so parallel lines would look something like this, X and Y. And I like to change the colors because why not? Here's one line, goes like this, nice pretty yellow. And the next one might be green, like that. Oh, I don't know, mine don't look super good. So there is no solution because they're parallel and they never cross. Okay, our last case scenario is infinitely many solutions. And this, I'm going to graph it. Here's my X, here's my Y, and change my color to lime green. That looks great. So I graph my first line right here. And then I look at my second equation and I go to graph it, and it's on top of the first one. So they're really the exact same line. So they might look different, like y equals 2x plus 6 versus 2y equals 4x plus 12, where I times by 2. So they're the same equation, maybe written slightly different. So you go to graph them and you're like, well, it's only one line. How many points will you have in common if they're the exact same line? Every single point. So now you have every single point in common. So that's where infinitely many solutions comes from. So those are our three types of solutions. Let me bear with me as I scroll back to the top of this document. And now there's three methods to get our three solutions. The first one is substitution. We use this when one of our equations is solved for y or x, and or easy to solve for y or x. And then what we do is we substitute one equation into the other. The addition method is, we like this method when it's in the form, standard form, like number x plus number y equals a number. And I'll give some examples, but we can eliminate a letter and we can do it like a big addition problem. So this could also be called elimination. Now, none of this elimination should be new. And if it is, that's fine too. So let's go through, and the last method is graphing. Graphing is probably only useful on a calculator because things don't cross perfectly and are super hard to see if you don't use technology. So graphing is a great method for technology, not a great method by hand, because you may get decimals and things like that. Okay, so let's look at these first two problems. And they do ask that we solve these by graphing. So if we look at this first one here, we could graph this. Do I want to graph it by hand? I think what we should do is, I'm just going to take a picture real quick so I have it quicker. Let's go into Desmos and I'll show you graphing it by the calculator here. Okay, so my first equation, I'm just in Desmos graphing calculator. You could use your handheld too. Or you could use Desmos, I don't mind. So our first equation was y equals 7x plus 10. And our second equation is y equals negative 4x minus 1. So here's our two. I can push I touched where they cross to get that negative 1, 3 to come up. So you can see there's two lines. They easily cross there. They cross really pretty at an easy spot. This is way more reliable than if we just graphed it by hand. So our answer for this first one was negative 1, 3. And how can we check that that's right? Well, we go, well, we did it on a calculator, so I'm pretty sure it's right. But we could check that by putting these values in for x and y, and it better solve both equations, because that's the idea, right? We're finding where they're both equal. So negative 1 could go in for x and 3 for y. So for the first one, it would be 3 equals 7 times negative 1 plus 10. Well, negative 7 plus 10 is 3 equals 3. So yes, the first one checked great. Let's do the second one. The second one would be 3 equals negative 4 times negative 1 minus 1. So a negative times a negative is a positive. So this would be positive 4 minus 1. I was thinking 3 equals 3. So this one is also 3 equals 3. So that worked for both equations. Okay. Okay, number 2 is the same. We could use the calculator. This one I could show by hand, pretty easy. So here's our x, here's our y, and we can graph this with y-intercept. So the first one starts at 5. So here's our y-intercept, and the slope is negative. So I go down 1 over 1, 1, 2, 3, 4, 5, down 1 over 1 from there. So there we go, negative 1, negative 2, something like that. And so this is our first equation. Okay. And then our second equation would be starting at negative 2 and then up 2 over 1, because you have to think of this as over 1 if you're wondering where that comes from, up 2 over 1. So here's our second equation. And I can easily see that they cross right there at 1, 0. Right? So 1, 0, it looks like is where they cross. We can check that by going in and plugging that in. So 0 equals negative 5 times 1 plus 5. Totally is 0 equals 0. Great. Second equation, 0 equals 2 times 1 minus 2, same, 0 equals 0. Great. So it worked. That's our solution. Okay, so graphing method could be done by hand, but I really do like graphing method on a calculator. Okay, now I know you could solve a lot of these on a calculator, and I want to make sure you can do it by hand as well. So some of your homework or your tests will be by hand. So look at problem These ones I want to use addition. It's kind of going through. I kind of want to skip around to get, because I'm the teacher, I can. So these all, maybe we'll do addition method first. It's fine. All four of the problems we're currently looking at are in the form number or X, Y, number. Okay, so if we look at this first problem right here, if I think of this as a huge addition problem, when I take and I add straight down, does one of the letters eliminate? So look, 2x plus 2x is 4x. That does not go to 0. Negative 2y plus 2y. Does that go to 0? Yes. So these would eliminate or go to 0. So we're going to do that. So we're going to treat this like a big addition problem. 2x plus 2x is 4x. Negative 2y plus 2y is 0. Okay, equals 24 plus 4 is 28. Then I can divide and I can find my x value is 7. Great. Am I done? No, I have to find y. I'm close. I'm halfway. So now I have to find y. So what I do is I put that 7 back in. So 2 times 7 minus 2y equals 24. Now this is where they're both equal. So could I use both equations, one or the other? Yes. I chose the first one. It doesn't matter. Okay, 2 times 7 is 14. So I'm going to subtract the 14 over. That goes to 0. I have negative 2y equals 24 minus 14 is 10. Divide over, and y is negative 5. Okay, so my final answer is x, y. That's the point where they cross. Could I then plug that in my calculator and make sure it's right? Sure. So let's look at problem 4 here. Okay, if I add 3x and 4x, does that make 0? No, it makes 7. Okay, does 3y and negative 1 make 0? Nope, makes 2. So we can't just eliminate straight down. So what we can do is times the bottom, every single thing, by a 3 so that there's a 3 right here, and that would allow the y's to cancel. If I wanted the x's to cancel, I would have to times this one by 4, this one by negative 3 in order for the x's to be 12 and negative 12. So it'd be a little harder to do the x. So if I times this one by 3, this would be a negative 3 and that one would be positive 3. So I'm going to do that. Okay, close up. Okay, so we're going to times this equation by 3. So we keep the top one the same. And then we'll times everything by 3. So 12x minus 3y equals 12. Now I can make it our big addition problem and eliminate a letter. So 12 plus 3 is 15x. These would eliminate to 0. And 18 and 12, 20, 30, right? Yep, 30. So divide by 15 and x is 2. All right, so then we plug that 2 back into any equation. I just will use the top one, that's fine. So 3 times 2 plus 3y equals 18. Been fighting off the hiccups, so do not make fun of me if I start hiccuping in our class. That'd be kind of during my video. So this is really 6, right? So I can minus the 6, 3y equals 12, and then divide, and I get 4. So our final answer is 2, 4. All right, so elimination method, and I don't need to do 5 and 6, but you can times any row by anything. You can eliminate x's, you can eliminate y's. So like this problem 5, I could times by 2 right here. That would help these eliminate. Ooh, let's do one more because this one's a tricky one. Ha ha ha. So we're going to just times by the 2 that we just were saying. So times 2 by that whole bottom one. Top one stays the same. And this will become 12x plus 4y equals negative 10. So I can now make a big addition problem. And what happens is everything cancels. So I'm left with 0 equals 0. When I'm left with 0 equals 0, then I'm left with infinitely many for our solution. If I'm left with 0 equals a number, then I'm left with no solution. But this one is infinitely many solutions. All right, infinite symbol, right? Okay. Nope, I was looking at 6. I was like, well, maybe we should do 6 too. This is kind of just telling us to solve them all a different way. Let's keep going. Let's look at 14. So 14 is set up with one equation being y equals and one being in the form xy number. Now, could I move the negative or the positive 2x over and make it negative and use elimination? Yeah, you can. But I'm going to show you substitution. This is already solved for y for us. So we can take this and substitute it in for y in the other one. So I'm taking part of one and putting it into the other as substitution method. Okay, so I'm going to take part of the top one, put it into the bottom. So when I write the bottom, it would be x plus, no longer having a y, I'm putting in the entire other function equals negative 2. Because they're where they're equal, we can do this. What it allows us to do is only have an x. We eliminated y so that we can solve for the x number. Okay, we didn't have a number out front of y. If we would have had a number here, then you would have had a number here and you would have had to distribute. But I don't have that on this one. It's a little bit easier. So then I really have x plus 2x is 3x. Plus the 1 equals negative 2. Keep solving. Minus 1 minus 1. I get 3x equals negative 3. Divide, and I get x is 1. Okay, now how do I find y? I take that x is 1 and substitute it back in up here. And I would use the top one because it's actually easier in the form y equals. So y equals 2 times 1 plus 1. So y would equal 3. So our point is 1, 3. Okay, so then you have to decide when I look at problem 15, maybe I moved that too quick. You could always pause your video though. Okay, so look at the 15. It's x, y number. What method should you use? Elimination or addition. Okay, look at 16. One of them's in the form y equals. What method should you use? You should use substitution. Take this, substitute it in for y. And we have only done one substitution, so let's do this one. So we're going to take this and plug it in here. So we'll only write out the bottom one. Negative 3x minus 13 equals 5 times, substitute the y in, 3x minus 17. Okay, and now we need to distribute. So negative 3x minus 13 equals 15x minus, oh, what is 5 times 17? 5 times 17 is 85. Okay, and then keep going. We got to get these x's together. So I can add the 3x, add the 3x. You could have gone the other way with the 15 as well. So that would go to 0. Negative 13 equals 18x minus 85. Now add my 85. And 85 minus 13 is 72. Positive 72 equals 18x because that goes to 0. Divide that by 18 and I get 4. Okay, plug that back into, let's use the top one. So y equals 3 times 4 that we got minus 17. So 12 minus 17 is a negative 5. Okay, so the point is 4, negative 5. All right. I am going to pause the video there and make a second video for the rest of this section. So this was part 1.